Good morning, ma'am. This is Bhavana. I am from Computer Science and Engineering Department. Today I am here to give a presentation on my topic, and my topic is component in architecture modeling. It is an important part of object-oriented analysis and design because it deals with how software systems are divided into manageable, reusable, and physical parts called components. Introduction. In software architecture, a component is defined as a physical and replaceable part of a system that provides the realization of one or more interfaces. Graphically, in UML, a component is represented as a rectangle with small tabs on its side. For example, in banking system, different components might handle authentication, transition, and report generation. Each of these components can be developed and maintained independently. Terms and concept. Every component in UML modeling have certain key characteristics. Names. Each component must have a unique name to distinguish it from another. A simple name refers only to the component's name, while a path name includes the package name and hierarchy. In diagram, components can include tagged values or additional compartments showing version, author, or other details. This naming helps in organizing and identifying components easily in large scale systems. Components and classes. Components and classes share many similarities. Both have names and interfaces. Both can participate in dependency, association, and generalization relationships. Both can have instance and nested. And however, there are some important differences. Classes represent logical abstraction like blueprint for object. Component, on other hand, the physical entities like executables or libraries that can exist in a file system. Classes have attributes and operations directly, whereas components expose operations only through interfaces. In short, when designing a system, if you are representing logical structure, use classes. If you are representing physical deployment, use components. Component and interfaces. An interface is a collection of operations that define a server, a class, or component provides. It's like a contrast between component specifying what a component can do, but but not how it does it do. In modern systems such as Java Beans, interfaces act as the glue that connects component. There are two main types of interfaces: export interface and import interfaces. For example, a payment component might export a process payment server service and import a verify user service and other component. Binary replaceability. A key feature of component-based architecture in binary replaceability. This means a component can be replaced by another component that provides the same interfaces without rebuilding or recompiling the entire system. The properties make software system flexible, reusable, and maintainable. For example, in an e-commerce system, if you want to upgrade the search component to make it faster, you can replace it long as it follows the same interface as the old one. But components are physical, replaceable, and system dependent. They exist as actual files and interact through well-defined interfaces. Organizing component. Organize You can also organize components by specifying dependencies, generalization, association. In UML, there are also standard stereotypes used for components: executable, library, table, file, and document. It helps standardize how components are represented across large systems. Standard elements are executable, library, table, file, and document. Modeling, common modeling techniques. Modeling tables, files, and documents. Apart from executable systems, also include files like data tables, configuration files, helps, documents, and logs. These are using stereotypes like file, stereotype, table, and document stereotypes. This ensures that every part of the system is documented and managed properly. Modeling an API. API stands for Application Programming Interface. It defines how components communicate. In UML, APIs are modeled as interfaces showing which component realizes them. Example interfaces might include applications, model, rendering, and script. These interfaces defines the operations that can be used by another component. Modeling source code. Components can also represent source files used to create executables. Modeling resource code helps in understanding compilation dependencies, versioning dependencies, configuration management. For example, a library render.dll might be built from files like render.h, poly.h, render.cpp. UML can be used to show these files related and depend on each other. Let develop tools manage files details where possible. Use UML mainly of documents and understanding code structure and dependencies. Thank you, ma'am.